projects that when I was in CSIRO I had a little bit to do with, but not a great deal. So this is called the MAGIC. I don't know if anyone's heard of the MAGIC program that CSIRO have. It stands for Multiple Advanced Generation Intercross. Yep. Really, for me, it's a really poor acronym, but anyway, we won't worry about that. I wasn't the person who came up with the idea, but what they've done here is they've got what's called a 4-way and an 8-way population. And in the 4-way population, they've taken a molecular marker survey of all the lines grown in Australia about 7 or 8 years ago, and they've said, okay, we're looking for the lines that encompass most of the diversity. The 4 lines they chose were Westonia, so Westonia from WA, Baxter from Queensland, Cara, and Yipti. So I think most people would know those lines. And what they've done is they've made the cross and they've done some intercrossing, which is the ICs. They've done intercrossing between the F1s, so they can break it up as much as possible. And then they've done huge amount of molecular investment on this. So, and now the trick is to actually start to really phenotype it for as many traits as possible. It was initially designed more around grain quality, but there's been a huge investment to get the population to this point. I don't want to tell you how many millions of dollars gone into it, but it's a lot. So CSIRO are trying to phenotype it for everything they can. There's a huge amount of diversity in here. As you can see, you've got some real tall stuff. There is double dwarfs, there's winters, there's springs, there's long springs, there's short springs, there's long winters, there's short winters. Everything's in here.
And what a soup of all those genetics.
Yep. And what it does is, so from those four parental lines, they ended up with 1,600 lines that they put through to yield testing, and then that 1,600 actually represents about 95% of the genetic diversity within the Australian gene pool that was there 7 or 8 years ago. Obviously, it doesn't include any of my stuff from New Zealand. But anyway, so if we talk through this a little bit, what that enables us to do from a genetic point of view, I don't want to go into too much detail and science here, but what that does from a genetic point of view is it lets us really get down to very fine map traits. So we can actually, some components of traits. I mean, we've now run what's called the 90K chip, or 90,000 markers. So we're looking for SNPs, so single nucleotide polymorphism. So it's just one base pair change, and it's really amazing that we've got 90,000 or 90 and a bit thousand data points on every single line here from the genomics. And what that enables us to do is go back and say, okay, well, this line was different from this line. How are they? What's the ancestry? How are they related, etc. And they can work it out, and they can go down to a very fine area. So instead of talking about in the old days, 10 or 5 years ago, we used to talk about QTLs, so that'd be a big region of the genome. That if you think of a chromosome like this, they used to talk about QTLs this sort of size. We're now talking about things like, I can't even describe how small it is, it's really fine. So what it's going to enable breeders to do is say, okay, well, you know what, I'm interested in that trait, I'm going to get this line, it's going to be the donor, and I can then track that very small, almost gene, and go forward in my breeding program. So they've done that with a 4-way. We've then done sorry, I should stop saying we, haven't I? Yes. CSIRO have also done an 8-way, where they've incorporated some of the parents from the 4-way, but they've also brought in material from overseas, from India, Europe, one from the US, and a couple from sort of your CIMMIT type programs. So one from Makata, one from CIMMIT, so from Mexico. So they've got and in that one they've got a huge. I mean, they haven't got quite as much genetic diversity captured there, but they've got, I think it's about 70% of the world capacity captured in the 8-way population. So this trial here, we're not collecting any. CSIRO are not collecting any data. It's really about making sure you've got pure seed to go forward into the real trials that are done in multi-locations. But from a genetic point of view, this is a hugely powerful resource that can be tapped into. GRDC are funding it, CSIRO are funding it, and some other multinational who shall remain anonymous are also funding it. But yeah, it's a big project. There's I mean, you can see there's people out here working right now, but I think there's about 20 odd people, CSIRO people employed full time just on this. We've got out of the Yanko site tomorrow. There's going to be helicopters going over taking aerial imaging for Canterbury temperature and ground cover and things like that, and they're doing, they're phenotyping the hell out of it, and they're going to get some huge gains for the Australian industry as we go forward.
Yeah, thanks. No, I think that's just to let you know what. I mean, I guess one of the things I'm pretty proud of is that this sort of stuff's happening in our backyard here. Yeah. And it's a great resource for Central West. It's good use of our land. It's research going on. It'll eventually benefit farmers. Probably it pays us better with growing commercial crop. So all in all, yeah.
Do I have to pay you?
Yeah. So all in all, it's just terrific to see it all happening. I mean, this sort of level of activity happening. This is incredibly valuable stuff.